This is my boy, Mike Simmons, right here.
How you doing, brother?
I always tell people he's smarter than he makes on. I asked him here recently to do a demonstration for a water class that we were doing, and Mike in his brain got to working.
It's dangerous in there.
I know that it's dangerous, but the stuff that comes out is awesome. And so I asked him to do this demo because I was just so impressed because I've never seen this before. And if anybody has seen this before, I would like to know about it. But I haven't seen anybody who has done it this effectively. That would probably be the best way. I met Mike up at Footlock 2, right? Up in Arkansas.
2019.
Yep. Walking on a cane.
Yeah.
Right? Got his pimp stride going.
Yep. Watch me walk.
We had spent like, what, 15 minutes together?
Oh, yeah. Yeah.
And
Made friends right off.
We've been friends ever since. So, how many years has that been now? I can't even remember.
It's going on 3 years now.
3 years or something like that? Yeah, time flies when you're having fun. But this guy has really done the work, and the science behind this is solid, I promise you. So, I cannot wait for you to demonstrate how this works. So, I'm going to let you.
All right, brother. Well, so what I've got for you is a demonstration on some of the aspects of filtration, emergency water procurement off the landscape, and this method that has been around for a long time and why it doesn't work. This is what we've always seen, is a pickle jar and a strip of an old cotton t-shirt, and the reason that it doesn't work is because this is not enough to work with the attributes that we're trying to maximize. We're trying to capitalize on cohesion, which is the tendency of water molecules to stick together, and we're trying to maximize gravity. This little strip of cotton cloth doesn't have enough surface area to transfer the water in a timely fashion. You're looking at 8, 10, 12 hours to get a cup of water, and in a survival situation, that's not going to sustain you. So for that reason, I or nobody that I know has ever incorporated this into part of our mental toolbox because it's not feasible to sustain us. So what I started thinking about was, well, what do I need to work on those things? I need surface area for those water molecules to travel. And then I also need absorption. That's another thing about this. A piece of old greasy t-shirt is what we always see. But even if we're in a survival situation and we cut a piece off of our t-shirt that we're wearing, it's going to have body oils on it, things like that inhibit absorption. Okay, so and if this can't absorb the water, then it can't transfer it along the cotton fibers. So it's basically making it water repellent rather than holding the water and getting it outside here to where the gravity can work on it and pull it through. Because it's the gravity that's going to pull the water through, and we're going to rely on the cohesion, kind of like a train rolling down the tracks. We're going to pull it with an engine, and the engine is gravity. So I started looking at, well, what else do I got? Well, I need surface area. And so I cut a piece off of an old towel, and I decided to see how that would work. I cut a wider strip, and then also a towel is designed to be absorbent, so it's going to soak up water. You see how it soaks it up really fast. And then take it and lay it over like this. And that started working pretty good. When I transferred over, I know that this takes sometimes up to 12 hours to get a cup of water. And I really need a lot more than that if I'm going to try to hydrate. And this right here was able to get me a pint of water in about an hour and a half, which was a huge improvement. We're getting close to being able to sustain my hydration here. Now granted, there's a difference between filtration and purification. Right now what I'm doing is I'm just filtering the visible particles out of the water. I'm not really doing anything to get stuff out of there that's going to make me necessarily sick. This is to try to remove visible particles, mud, silt, bugs, anything that I call crunchy or chewy. And so it's already starting to collect down the bottom. But there again, I want to provide enough surface area, and I want this to stay wet enough that the air doesn't dry it out. Because if we've got a nice breeze blowing, that's part of what happens with this like this. It dries out and then the wicking stops. So then I started thinking, well, what do I know about water? Well, water and air do not like to make 90-degree turns. They don't like to make abrupt changes. You lose velocity. And right now, with this, I'm trying to get the water to make in excess of a 90-degree turn, almost 180 degrees. And the forces that I'm trying to capitalize on, gravity and cohesion, that are beneficial on this side, are working against me on this side. So I need to try to keep the volume of my water up on this side and create a negative on this side so that it will actually draw over, and the same forces not fighting against me. So with water not liking to make 90-degree turns, water also moves sideways much easier than it moves up. And so if I want to try to reduce some of the forces, because I can't really do much of anything about the forces that I have on this side, I can't increase them any more than what they already are. So the only other option is to reduce on this side. And water wanting to move sideways far easier than it moves up, I said, well, I'll spread it out. I'll put it in a pie tin. I'll put it in a cookie sheet. And so therefore, I don't have the same effects of gravity pulling down on it. I'm just trying to move the water sideways. So I started with this. And I think you'll see that this, once it's saturated and everything, and there again. Now, I've done two things to increase my advantage. Not only have I reduced from a 180-degree turn to just simply a 90-degree turn, I've also reduced the amount of gravitational force on this side by spreading the water out.
You've also raised it up higher.
Slightly higher, yeah.
I'm talking and my mouth outruns my tongue. So, you can already see how much faster this is. Once I did this, I could get a pint of water in 45 minutes. Now we're getting really close. I would like to have a quart an hour is what I would like. If you're going to try to hydrate, you're going to try to do any personal hygiene, if you're going to try to, any kind of washing or anything like that, I would really like to have a quart an hour on average. And because I might actually have to run it through twice, there again, that's what I'm really looking for. And so that's getting, like we were getting really close, and I could go with that for the class that we were doing. But then I thought, is there anything else that I can do to improve this? I want this thing to work for me even if I'm disabled. This is kind of a passive system that I'm going to set up, and I need it to do as much as it can with as little input from me. Because if I'm calorically deficient, I'm not, I want to conserve as many of those calories as I possibly can. So then I started thinking about, well, what do I know? We're trying to do a wicking method. Well, what do I do? What do I know about other
Materials.
that have wicking properties? And well, first thing that came to mind was wool. And we always talk about wool for its wicking properties. And so we know that it takes water away from the skin really well, transfers it to the air and things like that. I didn't know. I never done anything like this before. This was the first time I ever tried to teach the class, and it was really just going to be about this method and why it doesn't work. And it just kind of evolved from there.
We usually teach these things so you can be smarter than we are.
So, so that people, when you're in a bad situation, you don't really have a whole lot of time to experiment. So if people can know what doesn't work, they can move on to something that does work. and not waste their time, because a lot of times you just don't have the opportunity for a redo. Well, first thing I noticed was that the wool took longer to saturate. Whereas this has the absorbency that I wanted and the surface area because of the loops in the towel and things like that. There's far more surface area for the water to grab onto and transfer over. Is that one still running?
It is slowly.
Very slowly.
So you can tell the wool takes a long time to saturate. But we'll give it just a second here. But there again, same width, roughly the same thickness material. We'll pull this back.
Look at that.
So it takes,
Constant drip.
you know, if I was able to get it over there where it will kind of free float like that.
Boom, 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 boom.
Is that not film or what?
Yeah.
You can actually see the water moving through the fibers. With the cotton, with the towels, the majority of the water is passing over the outside. The wool on initial test was better filtration because the water is actually passing between the fibers. And then not only that, it's doing it faster. I was able to get a pint of water in 23 minutes, filtered. In that time, I should have my fire going and be ready to boil in that time. And it's something that as long as I can keep water in this, I go gather my water and I bring it back, and that a pint of water in 23 minutes is really in excess of quarter an hour. You know you get 3 pints in an hour, but leaving myself a buffer to be able to run it through twice in case I had extra turbid water or something like that. That will work, and I knew it was something that really we needed to share with people if we could, because this is a passive system. Now granted, you're still going to have to boil it, but a lot of people like to carry the Sawyers, the Grail. This here would be a pre-filter for that, so, you know, before you run it through.
Or if you're trying to extricate like water from a source
Right.
that's out there in the, you know, like we were talking about a depression in the ground, like
For
a
sure.
puddle, or you're just trying to transfer the water so that you can actually get to wherever it is that you're doing the work.
Well, that was, and like I said, it's just we did a class and we had some scraps of wool blanket left over, and so it's just a 80-20 or 90-10 wool blanket that we did. But yeah, what you're talking about, and you know, we can't really carry a pie tin into the field with us. We're not likely going to have that. We're going to have a bottle of water or a water bottle, something similar to this. And so the next challenge was, how can I recreate this in the field? If all I carry with me is a bottle of water and a strip of wool cloth, or I've got, you know, a blanket that I might have to cut a strip off of or something like that. So the first thing that I would do would be to dig a hole similar to what you're going to do for like a Dakota fire pit. And you could actually do a Dakota fire pit, you know, so that you don't have any wasted effort. That's going to be where you boil your water. That's going to be where you do your cooking and things like that. Very calorie conservation, material conservation. You're going to get the most out of what you've got. But most of the time, we always have some kind of plastic, or there's something that can be procured off the landscape. There's Kroger bags, or you know, Piggly Wiggly
Trash
bags
bag.
everywhere. And so what I would do would be to dig a hole for my Dakota fire pit, set the bottle down in it, and at the top of the hole create a small depression, possibly even shallower and larger than this, because there again we're going to be reducing the amount of gravitational pull on the water and trying to speed this up as much as possible. And then just simply line this depression that I'm going to create with some kind of plastic.
A rain poncho even.
A rain
Whatever you
poncho,
got.
I mean some kind of rain gear, or you know, something like that. The cheap 99-cent emergency plastic ponchos, you know. So like I said, it's something that can be created in the field, but it's the knowledge that you can carry with you of something that will actually work, and it will produce enough water to actually sustain you as far as filtering out the crunchies and chewies.
Have you done like a, basic analysis, like putting it under a microscope to see the vast difference of impurities still left after those, like comparing them?
No, I haven't.
Well, the main thing is, and like he said, and I point out in some of my videos, you find a water source, but there's so much algae and swamp, and yeah, you can boil it, but you're still drinking dead bugs. He's extracting that, and he's getting you more of a pure product.
Right.
Plus, if you didn't have any other choice, there was no possibility of fire, you're greatly reducing your chance of anything else being in that water, and it would be safer than drinking the raw water.
Oh yeah.
So,
And you could do it multiple times.
yeah.
Well, and with being able to get, even if it took 30 minutes, something like that, you still be able to run through a pint of water an hour twice.
Mm-hmm.
And that's much better than something like this, or trying to set up a solar still. That was one of the things, on average, you'd have to set up 5 solar stills to be able to produce enough water to sustain yourself for, length of time. With something like this, you're really wasting your effort. It's going to cost you more than it's going to benefit you.
I've got a question.
Yes, sir.
Have you ever tried carbon felt?
No, sir. This was as far as I got. I would be interested. I don't know about the properties of that, but
They use it for welders' blankets,
right.
and you can buy it in Lowe's and Home Depot.
And I wonder if
Just cut you a strip of it and try it with that. And
right.
see how
Does it have carbon in the fibers of the activated charcoal, or
I don't know if it's activated or not, but
that would be really interesting.
if you have one of those fancy feast stoves,
Right.
That's what they use around for a wick, because it won't burn up. It
Right.
just transports the denatured alcohol.
I wonder if you had a roll about, say, 3 inches wide of that wool, about 18 inches long, and taper it that last 4 inches down to about a 3-inch wide by 6 inch. And if you took a dry bag, filled it full of water, and propped the dry bag up on the log where it come right out and dropped right over the edge of the log, you could probably suck a lot of water through that hunk of wool in a hurry and filter it directly out
And
of that.
it gets faster as this jar fills up. It actually gets faster because the level of the water is getting closer to the level of the water that you're trying to pull
More
from.
suction.
Right. And so it's just a little bit of science. There's a little bit of scientific method, and to encourage people that what it can be an effective survival tool. I mean, we all come from different walks of life, different backgrounds, different experiences, but
Part of this as well is the practical application of what resources you might have available or on you at the time as well. That was what impressed me, because a lot of people in this community carry wool blankets or they have wool clothing. I would definitely sacrifice a strip of that in an emergency to gain what you're producing with that material.
Wool blanket, wool scarf, wool glove.
absolutely.
Yeah.
Yeah.
And a lot of the knowledge, even though, that you don't necessarily have to be a survivalist to be a survivor. That's the thing. And a lot of the knowledge and experiences that we carry are directly transferable. It's just, it's not really in the forefront of our minds a lot of times. So, just like you bring up about, the welder's blankets, the carbon,
Carbon felt.
yeah. I mean, that's something I don't have any experience with, but it could be a very viable thing.
I wonder if the microfiber chamois, the thick ones that they sell for towels and stuff,
Yeah.
it's for wicking. Supposed to dry, right?
That carbon felt's about that thick.
Yeah. I just wondered though. But like I said, a dry bag that I could scoop up water, carry back to camp, and then just set it for the mouth openings at about like that kind of angle, and have the strip like that, put it into it, coming out, and just drop it straight over the edge of the log into a container? You've impressed me, sir. I'm gonna try this crap.
Well, the possibilities are endless, you know, and so there's a lot of things that I may not have any knowledge of, you know, things that might work. But can you guys think of anything that I forgot from the?
No, I just, from the last time we talked about the application of it, and then we talked about the depressions in the ground, etc. That would be a much better,
Yeah, wide
because they need
depression.
to know how to apply the principle of what you're teaching.
Right.
To them,
Well, I feel like
it's just practical.
the more I can spread that water out, the faster it's going to move. And we know water likes to wick sideways. I mean, if you spill water in the kitchen, it goes under the refrigerator. I mean, it wants to go sideways.
Plus, sideways, you've got greater atmospheric pressure bearing down on it.
Correct.
Your 15-pound PSI at sea level, and the narrow neck of that first jar, you're limited to like a 3-inch worth of atmosphere pressing down on it.
So we're trying
Whereas
to
that,
not only that, but push it through.
exactly. So it's trying, the atmosphere is bearing down on that water, and the wicking, like a roller coaster, sucks it up and over and out.
Once it starts,
The siphon keeps going till you run dry.
yeah.
You got a half jar right now.
I wonder how a piece of buckskin would do compared to that, because buckskin, brain tan buckskin, is wicking well.
Does it do the same?
Uh-huh.
And you're going to get, if you could get with that, the porosity, if that's a word, is going to be much smaller, and so you would actually get greater filtration, even though it may be a slower process.
Right.
But there again, like Blackie was talking about, getting a wider strip to compensate for that surface area that you need.
Well, we can try a piece of it after all this is done.
Okay.
I'd like to
That's
see.
a big deal too. If she said that you could do that.
Absolutely. Yeah.
I didn't say we're going to cut it.
Yeah.
Oh, there we go.
Ah,
So,
I already have
Well,
a strip that's cut.
thank you for the
Yes.
class, sir.
thank you.
Yes, thank you.
Awesome.